Hi, Spring fans. Welcome to another installment of Spring Tips. You know, I love spring. I think about spring all the time. I wonder all the time how I can better bring the spring. And that's why I do what I do every week on this series, is because I think there's just an endless opportunity here to sort of explore, innovate, I hate to use this word, delve into the wonderful mysteries of building enterprise applications. That said, it's worth, I think, sometimes revisiting the fundamentals. Back in 2011, I wrote a blog series called Green Beans on Ye Old Spring blog. This is actually the precursor to spring.io/blog, on which you've probably no doubt read a blog or two today. This is springsource.org. That content, by the way, is still available on spring.io. I just think it's interesting to know that the domain changed. Pretty big move if you think about it. Like, imagine abandoning a fairly, faithful domain for yet another one and it having it work out well in the end. It was a big bet on Spring Boot and the brand new opportunities that technology implied back in 2013. That said, that series was all about the amazing but humble Spring Bean. Now, you might wonder, what is a Spring Bean and why is it called a bean? Well, this, I think, traces its lineage way back to the 1990s and Visual Basic. At the time, it was the sort of well-ensconced leader in the space of rapid application development tools. You could take components that were packaged up in a reusable way and then literally drag them onto a palette, right? You'd assemble your business applications in a visual way using a what you see is what you get or WYSIWYG editor. So you'd add these components, and that could be a table, it could be buttons, it could be forms, it could be whatever. You'd add these components to this editor, and then you'd connect data sources. You say this table has data from this SQL database, and here's the query to run to populate it, right? And so you could easily build up these sort of thick client business applications and then easily compile them and distribute them in and around your Windows using organization. It was a really nice sort of paradigm. The code was a nightmare, but the productivity you felt at first cut, trying to write that code was sort of interesting. And when Java came out, remember, its forte in the very beginning was not the server side as we know it to dominate today. It was instead the sort of thick client world of applets, right? Web applications or client applications that were run inside the browser as a plugin using Java applets. And this is long before Flash and long before HTML5 and all the good stuff that we see in modern day JavaScript today. We had applets, and it was very, very interesting because Java, unlike Visual Basic and unlike so many of the other technologies before it, didn't care what platform you ran it on, right? You could run a Java applet on Linux, on BSD, on Mac OS, on Windows, on whatever, right? It was just a Solaris. I mean, it worked anywhere. And so it was a very natural sort of marriage with the web. And the idea was, hey, wouldn't it be great if we also had a sort of component model, a packaging and a set of conventions that allowed design time tools like Visual Studio did for Visual Basic to enumerate properties on components that we package and then distribute and deploy. Well, that was the Java Bean specification. The Java Bean specification, if you've ever seen a Java class with get foo and set foo, that's part of the Java Bean specification. Even if you're not even using Java Beans, and most of us aren't, certainly not in the capacity for which it was originally intended, you are probably going to use code in your daily life that adheres at least somewhat to this convention. There's a bit more to it. There's no argument constructors, there's events, there's more to it, but you don't need to know about that. The point is there is this way of describing components, and at the time, the thinking was it would just be visual components, the width of this button, the height of this table, the rows, whatever, the colors, and so you can enumerate that in your design time tool. And that would have been JDeveloper later, JBuilder in the beginning. I mean, Visual Age for Java, right? There's a lot of tools back then that gave you a sort of design time experiences. Even IntelliJ, I think, has a swing editor that will work in this way. Although if I'm honest, I haven't launched it in a decade or more, so I have no idea if it's still there or if it still works. I don't know. But the point is, this was part of the original sort of MO for Java. And, parallel tracks. I'm not sure which came first, but eventually in the Microsoft world, COM sort of became more. It became DCOM, and this is meant to serve business use cases on the server side, right? And this is a bit of a nightmare, so we won't go all that much into it, but it was kind of interesting. On the Java side, we had J2EE, or what would become Java EE, or now Jakarta EE, and of course, back in 2001, 2002, we had Spring. And the idea was that classes at this point that were sort of reusable and composable were all but synonymous in the Java world with the idea of a Java Bean. So we have this nomenclature that it was well entrenched, and it made sense, I guess, at the time to use the term Spring bean. But a bean is just an object that Spring manages. It's just an object whose properties, whose life cycle is managed by the framework, the application container, the application context. Although that said, back then we would talk first about the BeanFactory, which was the container of all these different beans that would give you instances of them. Things have gotten more interesting since. So today, my friends, we're going to go beyond the remit of that original 2011 series of blogs, because of course that would have focused entirely on the stuff that was available at the time, which has since been sort of exceeded. So today we're going to take a look at all that, as always, in our installation. So let's dive right into it. First things first, we're going to go to start.spring.io. And look, all we need is Maven and Java 21. We don't really need to do anything else here if we just wanted to, in the vacuum of Spring Framework, explore what it is to create and use beans. But I think it's useful to contextualize it in terms of something, so you can kind of see something working, right? Otherwise, you're just imagining objects getting created, which is as boring gets. So we're going to create a Grav. We can use GraalVM, of course. We can use Postgres. We might have Docker Compose. We might have JDBC, and that's a more realistic project. So let's go ahead and hit generate, and then open this up in the IDE. Okay, first things first. We have a public static void main application. We have a application that's going to connect to a Docker image. I've got that Docker image defined in a Docker Compose file. Here, we want this to be running on a separate port, and so we're going to go ahead and tell Spring not to bother. Tell Spring Boot not to bother creating that, because, well, first of all, Spring Boot doesn't exist in our initial examples. So we'll just manually start it up like this. And it's in the background there, and you can connect to it. PG password equals psql. U is called my user. H is localhost. And then the secret, of course, is secret and localhost and my database. Okay. And so there's nothing there just yet. We're going to initialize a table here. We'll say create table. Customer ID, serial primary key, name text not null, okay? And we'll insert some data into the table. So name values, like so. So select all from customers, nothing in there, okay? Just those 3 records. Okay, very good. So we've got our SQL database. Now let's look at our simple domain. We have a customer service. Ignore this for now. It's not, strictly speaking, necessary at the moment, but it will be later. Nothing is using it for now. It in turn expects a pointer to a JDBC client, and it's going to use that JDBC client to interact with our SQL database, returning some table, some data from the table. We have a callback here to validate the state after the application has been created, and of course we have a lowly Java record to represent the state from our SQL database. Okay, great. Now, what are the dependencies? Well, we're going to need a JDBC client. That in turn is going to need a data source. So we need to provide that. The data source will in turn need a pointer to a driver. So all of that needs to be created. One thing you're going to note is that we are using Postgres, but it's scoped to the runtime. I'm going to make it just, promote it to like top level there so I can access it in my Java code here. And we're going to start with a simple harness, if you will, that will execute code after each build. So let's go to our public static void main. We're not using Spring Boot, or at least not yet. We're not going to use any of that. Get rid of all that. Here is our basic, the harness, the framing of each example. Okay, we're going to look at a number of different examples here. They will live in between the start and the stop collection, and we'll just print out how long each one takes. Okay, so what are we going to do? Well, imagine the first example, static void 0. Okay, so we're going to say this and put that in there. We'll just say 0. Okay, there you go, very simple. So what are we going to do in 0? Well, we're going to create an application context a number of different ways, which is the container. It's the thing that contains all the beans. Actually, that's not true. The BeanFactory contains all the beans, and the application context is the thing that manages the lifecycle of that BeanFactory. That's why we call it the application context, because it's meant to manage the lifecycle of a BeanFactory so that it works well in the context of an application, a service, a monolith, whatever. So we'll have another method here, static void exercise, that takes a Spring application context and it does stuff with it. What's it going to do? Well, we'll ask it, we'll say, give me a bean of type customer service. Great. And we'll say for var customer in cs.getCustomers, just print out the data. Okay, pretty straightforward. So each one is expected to call that in their example, okay, given the chance. So the first kind of application context that we're going to look at here is based on a BeanFactory, okay? And I'm going to use something called a bean definition. Bean definitions live at the heart of the Spring framework. So here's our first example, okay? We're creating a BeanFactory of type default listable BeanFactory. We're creating a root bean definition for the driver. Remember, this is a Postgres driver. It has a no argument constructor, so nothing else need be specified here. And we're registering that bean definition with the factory, like so. Then we're creating a simple driver data source. Should you use this? No, definitely not. It even says so right here. This is not an actual connection pool. It does not actually pool connections. It just serves as a single drop-in replacement for a full-blown connection pool. So it's ideal for testing. And this is back in 2.5.5. long time ago, okay? And this, in turn, has constructor arguments. You can see here, it takes a driver, a URL, a username, and a password. So we need to satisfy those dependencies. We do so by getting a hold of the constructor argument values, and we're adding a generic argument value with a reference to another bean of type, with the bean name driver, and by specifying some values directly here as strings. We're hard-coding the strings in our Java code. Not a good look, we know that, right? This is the data source bean definition where it'll get registered here. We're also creating a bean of type JDBC client. The JDBC client doesn't have a constructor. Instead, it has this static factory method called create, which takes a pointer to a data source and it returns a JDBC client. Well, we need to account for that somehow. So we're telling Spring the definition of the bean is type JDBC client and the factory method name is called create. So when we talk about the constructor, we're talking about the factory method really. So the constructor argument values in this case for this type are not bound to its constructor, but they're destined for the parameters of this create method. And so what are we specifying for constructor arguments? The data source definition, right? We're passing in a reference to this data source bean definition that we just created a few steps earlier. And then we're registering that new bean definition as JDBC client, passing this in. Keep going. We have a customer service. The customer service has a constructor as well, and it expects a pointer to that newly minted JDBC client. So we give it a runtime bean reference to that, and we register the bean definition with a name customer service, passing in this customer service bean definition. And the whole thing gets assembled here as a generic application context, passing in the factory. We call refresh to force it to start basically, or to validate everything, and then we pass it to exercise. So if everything has gone to plan, let's go ahead and run this code and see what's what. Okay, so we got after property set, we got the 3 records from the SQL database, and we got the time, 0.27 seconds, so not even 0.3 seconds. What is that after property set? Well, in Spring Framework, forever, basically we have these callback interfaces, some of which we'll look at today, not nearly all of them, of course. One of them is initializing bean. This is a interface that gets called when Spring has created your bean, when it's created your object, but after you've passed in constructor arguments and after you've called set, properties, setters, right? So set foo, set bar. If you want to validate the state, if you want to do any last ditch validation, then you would do that here. There is a equivalent that gets called when you shut down the application. That's called disposable bean. And indeed today you can also use annotations. There's an at post construct, and you can put that on a method of almost any arbitrary signature like that. And that would work, right? Or setup or whatever you want, right? And there's a pre-destroy for destruction, right? So void destroy, like that. So you can use these in lieu of these interfaces, certainly. Today, they're basically interchangeable. One distinction, however, is that in the earliest sort of Spring Framework days, you have to enable annotation equivalents, whereas this always works. It doesn't matter what version of Spring you're using, this gets honored, right? And so the annotations, if they're present, may silently be ignored unless you opt into it. If you're using Spring Boot, then of course you're already opted into it. Don't worry about it. But in the old days, that was an interesting distinction worth making. Okay, so this whole thing is up and running, but it's a little bit verbose, obviously, but it's nice to know about this. These bean definitions are the heart of Spring Framework. Every bean that you create in your application, be it from Java configuration, from XML, from functional config, from anything, all of them ultimately ends up in this just giant big bean factory full of bean definitions, and they can see each other. A bean definition created via Java config can see a bean created via XML, and they are all sort of normalized into bean definitions, which is nice, right? And this is actually a pretty big deal if you consider the prevailing technology at the time, something like J2EE, where, and this is still somewhat true today, but especially then, they were independent siloed component models, if they could even be called component models, right? An EJB couldn't, like a servlet couldn't inject an EJB, etc. Okay, so that's 0. This is the primordial soup of Spring Framework. And there are lifecycle callback methods that you can interact with, like this this method, this interface here, if you implement this on one of your beans, then it'll get a chance at the very earliest stages of the application context initialization to get a pointer to this BeanFactory. And there, it's expected you will only work in terms of the bean definition interface. You will not use full realized created beans, right? And at this point, you can actually, things are still fluid. There's the primordial soup of the application, so you can actually destroy existing bean definitions, register new ones. You can actually, you could still do very dynamic things at this point. And so we did lots of interesting things here, like people created beans by connecting to a database and then reading some information from there, for example, or whatever. You could have a .ini file, or later a .properties file, or you could have whatever. You could dynamically create beans in this way by registering beans using this low-level interface. The only trick was you had to do it without the support of other beans in the context, right? Because, for example, that example I just gave you of talking to a data source, the data source hasn't been created yet. It's in Spring. Spring is still just bean definitions. You can't use the data source to then talk to a SQL database to get the information that's used to then create the bean definitions. Okay, so let's move on. What can we do to improve that? Well, one step forward might be to use the XML. So we're going to say one. Okay, so we're going to create a XML context, new class path, XML application context, passing in beans1.xml. I'm going to call exercise, passing that in. Okay. Now, what is beans1.xml? Well, it's a Spring XML bean configuration file. This is, you shouldn't, I would never use this today. There's no point, right? I have Java config, but it is kind of interesting as a sort of archaeological sort of artifact, right? And you can see we're defining how these beans are created. We have a bean with ID driver, and the class is driver. We have a simple driver data source. It expects a reference to the driver and has string values, hard-coded again here in the XML. We have the JDBC client. We have to specify the factory method, pointing it to the create, JDBC client.create method, passing in for the constructor, the driver data source. We have the customer service bean. In turn, it expects a pointer to the JDBC client. So all this is more or less the same as what we had here with the bean definitions. Let's go ahead and modify the code to support that now. Okay. Restart. Exactly the same. It's taking not like, it's like, what is it? 50 milliseconds more or something like that. It wasn't that much, right? But it is taking a little bit longer, okay? And we understand what's happening here. Can we make this a little bit cleaner? Maybe we can finally avoid hard coding these property values here. Well, we could do that. One way to do that is to create a new file. Okay, so here we're going to use beans2.xml. We'll call this 2, and 2.xml is a little bit different. We're using a namespace, okay? So namespaces are a thing that, actually I'm skipping ahead a little bit here, but namespaces were introduced in Spring Framework 2.0, and they gave us the ability to, given one line of XML stanza, create multiple beans. So we can actually create really interesting DSLs here, and we did. If you look at that era in the Spring history, you had Spring Batch, you had Spring Integration, you had Spring Security, all of whom benefited tremendously from this amazing mechanism. We could create a single schema contextualized to a namespace, and you could specify a few attributes, and then that would resulted perhaps in the creation of a lot of different objects cooperating. In this case, all we're doing is loading an application.properties file to grab these keys and values, these property values from the property file. Well, of course, these are Spring Boot properties, right? But this is long before Spring Boot. So we'll go here, we'll say Spring secret URL, username is my user, URL is jdbc:/postgresql localhost my database. Okay, and that's basically it. So we can run the program now. Do we get the same results? We should. Okay, we did. A little bit slower still, but still basically just very, very quick, right? Much less than a second on all counts. The XML for beans-2.xml. Let's go ahead and run this program and just see what that gives us. All right, so 0.32, so a little bit slower than the first one, not really, but it's loading the extra property file, and we can see that result there. Okay, very good example of namespaces. Moving on, what can we do to simplify this even further still? The second example here, it's fine, right? It's not so bad, it's fairly understandable, but you can kind of see that eventually with enough of these small little micro beans or tiny little bean definitions, eventually things are going to start, it'll be easy to start losing the forest for the trees, right? And I want to be able to hide some of the innate complexity of complex objects if I can, and especially if those things have lots of different configuration parameters. So let's suppose I was, doing the wrong thing, and I wanted only one data source in my application context, and I wanted it specifically to serve the purposes of creating this JDBC client, right? So I wanted some way to create a JDBC client that in turn created a driver and then created a data source. Here, I've got 3 different beans, and I want to create them all in one fell swoop. I don't want to create 3 beans, I just want to create the JDBC client, and these other things are dependencies for that. And the example I'm giving is a little bit contrived, but you can imagine really anything that requires a lot of objects that you need to write Java code for, and that requires parameters, right? For this, Spring has the concept of the factory bean, and the factory bean is, it's just that, it's a factory for beans. The contract has been in Spring since basically the very beginning. You can see the concept has been in Spring since 2003, and it's an object that when Spring sees it, it'll manage not the factory bean itself, but the product of that factory bean, the thing that gets returned from getObject. And what is the thing that gets returned from getObject? Well, it's whatever this class is, right? It's an implementation or instance of that class. Let's rework our example here in favor of factory bean. So we have a new factory bean, and this takes 3 setters, so 3 settable properties: URL, username, and password. These properties are going to be used to create a new instance of our object. So we create up the driver, don't need a bean definition. We create the simple driver data source, passing in the driver and the URL and the username and the password. The user configures these 3 strings. Everything else gets handled within this getObject call. So we need to wire this bean definition up in our XML. So let's now create beans-3.xml. Okay, we're going to go here and we're going to rework some of this code. We no longer need this, we no longer need that, and we don't need this, right? We're going to create a new JDBC client like so. So JDBC client class com example beans.JDBC client factory bean, and we're going to provide the properties here for the username, which is value, and the username is my user. The password is secret. The URL is JDBC :postgres QL localhost my database. Now, of course, this is just fine, but we did all that work to extract all that into properties, so let's just inject that instead. So here's the URL, password, and the username. Okay, pretty straightforward. So we have a JDBC client. It in turn is expecting, it's a factory bean for the JDBC client. Our customer service is expecting a pointer to the JDBC client. Okay, so let's modify this code now to use beans3.xml. Call that 3. Go down here, 3. Very good. And let's just rerun it with that change. There you go, exactly the same result, but now we've dramatically simplified the code here. We've hidden some of the intrinsic complexity there behind this JDBC client factory bean. Would I do that in this particular example? No, but I think you can kind of understand what's happening. Now, in point of fact, we don't often use factory beans anymore because, well, we have Java config, right? We don't need this escape hatch, right? This is a sort of way to compose bean definitions without having to wire up a bunch of XML or write a namespace handler. This predates the namespaces in XML, of course, but I think the result is still very useful. Now, here I've got this bean called the customer service. Wouldn't it be nice if I could just discover this bean automatically, right? Because this is my business logic. I'm willing to do whatever I need to annotate it so that the fact of the registration of this bean with Spring lives with the definition of this class. And I can do that with component scanning. So let's create a new version of this code called beans4. And here in this, we'll call this OUR. And we'll create a new method here, FOUR4. Okay, there we go. So there's 4, and what we're going to do is we're going to go to 4 and just enable component scanning. We'll get rid of that definition there. And component scan com.example.beans. Okay, so there's my updated code. It's going to now discover all beans that have been annotated with anything with @component, right? This is called a stereotype annotation. It's the marker annotation that tells Spring that this class should be created. It should try and satisfy all the constructor arguments with other beans in the context that match the parameter types, or if it doesn't have any parameters, if there's a constructor with no parameters, it'll call that. And it just basically assumes we want like the regular treatment, create a singleton, satisfy the dependencies, call the constructor, all that kind of stuff, call the lifecycle, and so on. @component is the root, but others are in turn tagged with that. So @service as an annotation has @component, right? @controller is what we use for like Spring MVC style controllers. It in turn has at component. If you look at rest controller, right, here we go. Where's this one? Oh, it's not in the class path, I guess, but well, there. Well, anyway, at rest controller in turn is annotated with at controller. So all of these ultimately, if you do a little recursion, you can ultimately find at component at the root, and Spring does just that. So at service is ultimately a component with some extra benefits, but they're still basically components. And when we use these annotations, we call them stereotype annotations. That is to say, they are documentational as well as functional, right? They are in the sense of UML stereotype definitions, right? That is to say, they define an archetype. So this is a service. Spring will find it as long as it exists in this package called com example beans, which is what we told Spring to look for in our XML here, right? So component scanning for that. So let's go ahead and run this. Let's make sure we've pointed our program to 4. Let's run this again. And now we get the exact same results. And it's actually looking for all classes in that package. And the result is the XML gets smaller and smaller and smaller. But we still have this JDBC client factory bean, and even if we didn't have this, we'd have the other definitions as well. So, and that's a lot of, there's a lot of third-party classes that we need to wire up. But we're doing it in XML. Wouldn't it be nice if we could do that in Java configuration? Well, we can. Let's look at our next example. Here's our Java configuration. It's a Java configuration class. It has a special meaning, that is to say, this tells Spring that this class is capable of defining bean definitions, or of defining the beans themselves, right? It's at configuration, but remember what we said about stereotype annotations. At configuration is a component as well. It's just a special kind of component that is going to be inspected for at bean definitions that produce beans, okay? So yeah, this is very convenient. We have JDBC client, we have our data source, and we have the constructor. We could do more, but I think this will get us back to where we were. We're also telling Spring to load some properties in the property source via this mechanism. So this is akin to the property placeholder resolution that we saw earlier, but instead we're using the environment, right? And the environment allows us to look up properties that have been loaded via this property source into the environment. And we could also use the property placeholder syntax if we wanted to. We could use at value Spring data source username, right? And then replace the username here with that. Ultimately, this goes to the environment.get property. So if you do this in an annotation, ultimately it results in a call to environment.get property. It's up to you which one you prefer. You can mix and match as I'm about to do here. Either way, very convenient. And we have at component scan, that's the equivalent of the XML component scanning. And then we have a profile. This is a mechanism that we introduced into Spring that tells Spring that this is only to be active when a profile is activated. So this bean definition is only activated when we explicitly activate this profile. How do you do that? Well, most commonly, you do that via a command line switch. Let's go ahead and use this new mechanism, this application annotation config in our example. So here's the 5th one, we're setting a system property, which is kind of like setting it on the command line. Spring.profiles.active is 5. Then we create another kind of application context. This time, not a class path XML application context or a generic application context, but instead a annotation config application context, passing in this Java configuration class that we just defined. So this will have the effect of telling Spring to activate all beans in the 5 profile. Remember, this is in the 5 profile, and we can change this now to use that. We can restart, and there we go, 0.33 seconds. And the results are all there, right? Same basic arrangement here as before, but now we've completely moved beyond XML. There is no more XML in this example. We're using Java configuration. As you can see, it's still plenty fast, but it's not as fast as, say, the very first one that we looked at earlier, which was bean definitions. The problem with bean definitions, unfortunately, is that it's very low level. Most of us don't want to think about, our object domain in terms of the stringly, properties on the objects and bean definitions and all that, right? We want to think about objects themselves, right? We want to wire them up ourselves explicitly. And so the question was asked, well, is there a way to sort of sidestep all the reflection and annotation processing and XML ingest and property file loading and all that stuff that we saw earlier, while also getting really, really low memory, right? And we created something called functional configuration in Spring Framework 5. Technically, the functional configuration came after the Java configuration, but it is a bit more verbose. So let's take a look at that here. So here's our 6th application. So here's our sixth application. We're creating a generic application context. We're registering beans programmatically here. This is not a bean definition. This is actually objects in our object graph, and we're programmatically telling Spring which objects to instantiate. And if it requires anything more than just a no argument constructor, we're telling it how to create the objects themselves. So here we've got the customer service. We're telling it to just create an instance of that. It's going to do that by inspecting the customer service for the constructor and finding the constructor arguments. So there's a bit of reflection there. It's going to need at some point we're going to need a driver. We're going to need the environment. The environment in turn needs the property sources that points to the application.properties. So we're registering all that. And of course we need our simple driver data source. Here we're telling it register a bean of type with the ID simple driver data source of type data source. And here's a supplier. This supplier tells Spring how to instantiate, how to wire up, how to new up an instance of this object. And we're delegating to the environment to get the URL, the username, and the password. Here we're registering the JDBC client, again, calling JDBC client.create. We don't have to do anything special. Notice that in order to get the collaborating objects, I have to go to the generic application context up here. So whenever you see me say gac.getBean, I'm actually getting a bean from the context itself, right? There's no auto wiring or anything like that. And so I'm calling JDBC client.create, get bean data source, calling new customer service, calling get bean JDBC client, and so on. I'm going to call refresh, and then I call exercise. So this is the sixth iteration of our code. Let's go ahead and run that. Okay, run much faster. Did you notice that we saved almost 100 milliseconds on that? We're back into the levels of performance basically as we had in the very first one when we used bean definitions. But it's a bit higher level, right? And this is a little bit more verbose, I think, than, for example, Java config or even just XML component scanning or Java component scanning. But it's in terms of our domain. The only things you're worrying about here are get bean from the Spring application context and your domain model, the objects in your application, right? So it's a nice mix, and this avoids a lot of reflection as well. So it's not surprising that we use this for a project called Kofu and Jafu. These are not like official projects, but they were Kotlin functional Spring and Java functional Spring, right? So these are side projects that were kind of experiments, research beds, if you will. And this mechanism, by the way, if you use GraalVM and the native image compilation support in Spring Framework 6.0 and later, the AOT engine, behind the scenes, we take your Java configuration and your XML and all these other bean definitions, and we write them out back into new Java source code files using functional configuration here. So this ends up being the sort of reified version of everything else that you provide. If you use GraalVM native images, you can actually inspect the source code that we generate during the build process in the target or build directory. They're actually in an AOT folder usually there, and you can actually inspect the functional bean definitions that we created by analyzing the bean definitions at runtime during the compilation. I know that's a bit weird, but if you know about how the GraalVM AOT support works, we actually create a BeanFactory containing bean definitions. Nothing more. We don't actually create the objects, but we create the bean definitions. Then we visit those bean definitions and basically write out in Java code a recipe using functional bean definitions for recreating that same BeanFactory without XML, without component scanning, without as much reflection, etc. So this is a very, very nice alternative to using the other approaches. It's high level enough that I think most people are probably going to be okay if they just use that. There are various overloads here. You've got the bean name, the class name, but you can also just provide the bean class. I'm providing the bean name so as to keep continuity with what we saw earlier, but you could just provide the bean class and then the customizer, or the supplier and then the customizer, and so on. And now we've gone through all of the sort of core Spring Framework configuration mechanisms, and it's all, there's pros and cons to each of them, certainly. Let's bring back our old friend Spring Boot and see what that does. So here's our 7. We're going to call 7. Here's our 7. We're going to call Spring application.run, passing in beans application.class. That's our public static void main Java class here. It is going to, in turn, look for our old friend Spring Boot application. I'm going to add Spring Boot application to the class, and then we'll just change our code to use 7. Okay, so here's 7, the 7th iteration of our code. We're going to just call Spring application.run, beans application.class, passing in the arguments here from public static void main. We have to add Spring Boot application to the Java class, but otherwise everything is the same. And did you notice that Spring application.run returns, yes, an application context, so we can pass that in to our old friend exercise. And now we don't have Java config that we have to worry about, right? This is not active anymore, so that you can effectively ignore this one. It has these Java configuration classes, these bean definitions, but it's not being activated. So you can imagine that we didn't have to write this at all. Let's go ahead and run this and see what we get. There's our application, 0.46 seconds, so a couple hundred milliseconds slower, I guess, than before. But the result is we didn't have to create the data source, we didn't have to create the JVC client, didn't have to create the anything really. All this other stuff, if you look at it, all that goes away. It's just public static void main, and we have some properties, and we created the customer service, right? That's it. Everything else was done for us. So if we strip away all the other code, get rid of all of that, get rid of that, and actually this whole class right here, get rid of all that, get rid of all the other implementations here, get rid of all that, and then of course just ignore the XML because it's not being loaded at all. So the sum total for our application is the record. It's this trivial one line. I've got multiple lines, but it's a one-liner fluid DSL to make a SQL query. And then we've got public static void main. I've made it very complex by debugging it. The only thing that's left really is this logic here where I'm calling, I'm using Spring to get the application context and I get the beans that I care about. And then I call the service and I get the results from the service. But even here, like in Spring Boot, there's a callback interface that I can register that gets run right after the application has been initialized. And it's just a bean. So I can return a bean of this type, like so, and inject the customer service directly, right? And just do that. So I'll call that CS. Very good. This is a lambda if I want it to be, or it could be a full bean. So now I don't need that either. I don't need this. Don't need that. And indeed, you can put this in public static void main altogether, can't you? Right? So there you go. And Spring Boot already prints out how long it takes to start up. So we can get rid of all that as well, okay? So we can rerun this. There's the results. We get the data source automatically created, the connection, and this is a real connection pool, not my simple driver data source thing. We get the 0.36 seconds, roughly on par with what we saw earlier, and so on. So all this is a better result. Now the question you might have is, how is all that working? Well, behind the scenes, the magic to Spring Boot is this thing called autoconfiguration.import, right? It's a file, and it's in the meta-inf directory of various jars, including your own jars. You can create your own meta-inf/spring/org/spring-framework.boot, org.springframework.boot.autoconfigure.autoconfiguration.imports file, and then put these Java configuration classes. And these Java configuration classes will automatically be loaded when Spring Boot starts up, right? So you can see I've got, let's say we have this one. Okay, I'm gonna go here, load that Java class, and you can see that this in turn is auto configuration, but it in turn is actually just configuration. And it has, guess what, bean definitions, and it takes dependencies here, right? So this is all very much in line with what we saw before, but we also have these extra benefits, these guards, these tests that get evaluated before the Spring application tries to instantiate these beans. This is the next sort of level here. This is the thing that makes Spring Boot different from the rest of Spring, which is the heavy use of these conditions to look for the presence of classes, to see if there's other beans already registered of this type, to look for, to enable configuration properties, etc. But ultimately, behind the scenes, what you're dealing with is exactly the same as everything else we've seen. And ultimately, behind the scenes, those bean definitions and all the other beans that you register via component scanning and so on, all get registered as bean definitions. And if I wanted to then compile this very simple application into a GraalVM native image, I could go to the command line here and kick off a compilation. Okay, the compilation is finished in 29 seconds on my machine. I'm gonna run beans, and there we go. There's the application. Started up in 0.031 seconds, so 31 milliseconds, not 300 like we saw even, 250, 300 for the very fastest of the other examples. And, it's Hikari and all that stuff. Remember what I told you about the functional config? You go to the target directory here, go to Spring AOT, go to sources, go to com example beans, and you can see here, we've got these bean instance suppliers that ultimately end up in this Java class, bean application, BeanFactory registrations, and we're using register bean definitions, right? And these methods behind the scenes are registering bean definition objects for us based on our classes, based on our application, based on all the dependencies. So this is the transpiled functional sort of definition of everything that we have in our program, even though our program was using Java config and annotations and so on. All right, does that make things clearer? Does that help? Does it confuse? I hope it's sort of more approachable. For 99% of the stuff you do, you don't need to worry about most of that, right? Just use @Spring Boot application, use @Bean for the occasional third-party library that you want to wire up. And by the way, you can see I'm injecting collaborating objects here like that, very easy. And then use @Component, @Service, @Controller, @Risk Controller, @Repository, and Friends for stereotype annotations. And then you're done. You'll probably never have to worry about XML. You'll probably never have to worry about functional config. You'll probably never have to worry about Bean definitions. But it's just nice to know on what all this stuff stands, right? The humble Bean, it turns out, is very powerful, and it exists at different phases in the Spring life cycle. Friends, don't forget, as always, to like and subscribe. If you enjoyed this, thank you very much for paying attention and sticking around this long. As always, thanks for watching, and we'll see you next week.